in your note packet for B5, we're going to have a little bit of extra, like some warm-up type stuff. But if you go back one page, okay, so if you go back one page, there's a bunch of open space down here at the bottom. That's where you can do the warm-up problems for today. So at the end of B4 is the open space where you can do these 4 problems. So we're doing these 4 problems first. So we're doing 2 order of operations and 2 simplified problems, please. So please do that right now. Go. Right. 2 minus -3. So that's really like what? 2 plus 3 right here. Okay. So that's going to be 5. Then we've got still plus a -4, which is really like 5 minus 4. So that would be what? Good job, what? Okay. All right. 1. What do we get for number 2? We got 9. 9. Everybody got 9? Maybe? Yeah, let's see. Okay, what are we going to do first? We're going to do 7 plus 4 because it's in a set of parentheses first. Yes. What is -7 plus 4? -3, right? Okay. So then this is 3 times -4 plus 3 minus 6 times -3.
Let's do one thing at a time.
Yep. Okay. Not trying to do too much, because then we get out of our order, right? Okay. What's next? So multiplying and dividing, right? So because we're done with parentheses. We don't have any extra ones, so we got to do multiplying and dividing. We got to do that left to right. Okay. So first off, we're going to do this. 3 times -4 is -12 plus 3 minus 6 times -3. Then we got to do this one right here. Okay. So then that's going to be -12 plus 3, what? Minus -18? Or plus -18? Plus negative? Do we agree with plus negative? Wait, no? Because look at, what do we got? We got a negative times a negative, right? Positive or negative? Positive, right? Because it's positive. Negative times negative is positive. So it would be plus 18 or minus -18. -12 plus 3? Negative what? -9? Run out of colors. -9 plus 18?
Final answer of
9. Positive 9. Yep, good job. Good job, Aaron. Oh. Alright, so I like that one. I like those 2 so far. Simplifying fractions. This was from Monday now. Okay? So, is there a number that goes into both 12 and 18? 6 is one of them. What's another one, just in case we didn't do 6? 3 and 2. Yep, okay. So all 3 of those numbers go into it. Now, the biggest one was 6. So if we choose the biggest one, we probably only have to do 1 reduction. If we chose 2 or 3, we have to do another reduction because we still wouldn't be in completely reduced form. Okay? Right? So I'll do that both ways. So if I do dividing by 3, let's say, then that's going to give me 12 divided by 3 is 12 divided by 3 is, boy, 4. 18 divided by 3 is 6. So I got 4, 6. Easiest way to tell it, both of those are even numbers. Okay? So for sure they both can be divided by 2. So if I divide both of those then by 2 again, Then I get 4 divided by 2 is 2. 6 divided by 2 is 3. So 2/3 is my answer. Could have done that all in one step by dividing by 6 right from the start. But I wanted to show it to you.
Explain how like those two things, 2 and 3, are be the same as 2 and 6.
Because what is 3 times 2? 6. So that's why we can divide by 6. Okay? Now, I will tell you this also. Remember that, yes, we started with 12/18. Yes, technically we reduced it to 4/6. But that would still be wrong because there's more reducing to be done. Okay? It's like going to Stevens Point. If we get on the highway right over here and we go south on 51 to Stevens Point, if we stop in Mosinee, are we in Stevens Point? No, we're not. We're on the way there, but we're not fully there yet. Okay? So you got to get all the way there. Okay? 25 and 15, biggest number that goes into both. 5, right? Okay. So what is 25 divided by 5? That's 5. Yep. And what is 15 divided by 5? 3. So my final answer here would be 5/3. Okay.
What's my favorite? Anything that isn't 5? 5 or 0?
5 or 0. Your only two choices. Yep. Always divisible by 5. Oh, yep, we got to finish it up. Sorry. What's up? Oh, make it into a mixed number? Yes, we could. So what you're saying is then we could take it to what we learned yesterday, and we could take this and we could go, or you said 1 2/3, like that. Yep, I would accept both of those. Yep, good job. Okay. All right, 2 more. There we go. All right. So 12/5, write that as a mixed up number, and write 3 2/7 as an improper fraction. Go. So writing it as a mixed number, what do we do first? Okay, how many times does 5 go into 12 evenly? How many times does 5 go into 12 evenly? Twice, okay? Alright? So it goes in there twice. Now remember, we had a couple of different ways. We could say 5 goes into 5 once, 5 goes into 10 twice, 10 is still smaller than 12. 5 goes into 15 3 times, but 15 is bigger than 12. It's like, you guys ever watch the game Price is Right on TV? In the summer? I mean, that's like my summer jam. My wife watches Maury at like 9, and then I watch The Price is Right at 10. Okay? And I've done that every summer for like ever. Because it's awesome. And you play The Price is Right. Well, in The Price is Right, you're guessing the price of these values. So like if I'm guessing the price of that phone, I have to be closest to it, but I can't go over it. Okay? So that's like what writing as a mixed number
I think
is.
we should watch that tomorrow on the
Oh, that's that. Tomorrow would be a great day to watch Price is Right. Yeah.
get us started. Okay.
Okay? So 5 goes into 12 twice. But then it doesn't go in 100%, right? So what's left over? 2. There's 2 left over because we get from 10 to 12 is 2. So we write that as 2/5.
Same denominator, yes.
Okay? Same denominator. This denominator goes right in there. Okay? How many times it goes in? What's left over? Okay? Writing it going the other way, from a mixed up number to an improper fraction. Okay, now we work the clock. First thing that we do in this particular one. First thing that we do is multiply 7 times 3. Okay, not add. Okay, multiply 7 times 3. Okay, what is 7? 7 times 3. That's 21. Then what? Then we add the top, so that's 23. And then we put that over our denominator 7. Okay? So 23/7. All right?
Mr. Linsmeyer, what if they're on number 5, and they're like, I don't know if my answer's right.
Oh, we could always, when you get an answer, you can always do the other one
Yeah.
to fix out to make sure it's done right. Okay? Well, Mr. H is saying there, so you got 2 2/5. You want to check it to make it right. You do what you did in number 6 to get your answer again. Likewise, in number 6, to know if you did it right, you do what you did in number 5 to check your work. Okay? You do the other one.
So if we check number 5 real quickly. If we had 2 times 5, that gives us 10. 10 plus 2 is 12, so 12/5 is what we have. You can always check your answer, like on an assessment or a test before you turn it in. I know you all work so fast, you get done early, just check your answer. Your time. Okay. Any questions on those two?
So, just so you're all aware, like I was trying to figure out where this noise was coming from over here, and it turns out when I touched my watch, my phone was playing music. And so I was listening to Bon Jovi's Bad Medicine up here, apparently. Who would have known? Good song, I know. All right, so now we're going to get into our B5 notes. So now you're on the next full page. Okay? So B5 notes. Today what we're going to do is we're going to put rational numbers on a number line. We've done this before. Okay? We did it lots in Unit A. We've done it here in Unit B. We put irrational numbers on number lines. Okay? But now today we're gonna go with weird ones because we're gonna have fractions today that we're gonna place in between two numbers. Okay? So we're gonna put the fractions today on the number line. Okay? So for instance, 3/5 is a fraction. It's less than 1. How do I know that a fraction is less than 1? Oh, 3 is bigger than 1. I can shout out random numbers too. 87. You know what I mean? How do I know that a fraction? We learned this yesterday. Okay? We learned this yesterday. How do I know that a fraction is less than 1? How do we know that a fraction is less than 1? Yesterday we learned why a fraction was bigger than 1. So let's use that to figure out how we know a fraction is less than 1. From our notes from yesterday, not just randomly shouting out things. From our notes yesterday, how do I know that a fraction is bigger than 1? How do I know from your notes yesterday, literally one page before this, how do I know that a fraction is bigger than 1? Might be an improper fraction.
Any luck? Some of you looking.
It might be exactly what we said for an improper fraction. The definition of an improper fraction from yesterday, one page back, is what? So you said what again? So a fraction that's bigger than 1 has a numerator. Is that top or is that bottom? Is that top or is that bottom? Everybody, is that top or is that bottom? Top. So the top is what? Bigger than the bottom. If a fraction is bigger than 1, the top is bigger than the bottom. Okay? Now I'm going to make you think. How do I know that a fraction is less than 1? Top is smaller than the bottom. Every fraction, write this down because you guys are struggling with this. So right at the top of your B5 notes, a fraction is less than 1 if the top is smaller than the bottom. Top, smaller, bottom, fraction less than 1. Top, bigger, fraction bigger than 1. See that relationship? Top bigger than 1, bigger than the bottom, it's bigger than 1. Top smaller than the bottom, fraction smaller than 1. Okay? What we're doing today is we're going to put fractions between two numbers, between the number that's bigger than what the fraction is and the number that's smaller. Okay? So the fraction is going to be placed between the bigger. Actually, you know what? I don't even want to write that down. I don't even want to write that down because I don't. Yeah. We're just gonna do it. Okay? We're just gonna do it. Okay. So 3/5 is less than 1, correct? Why is 3/5 less than 1? Because the numerator is smaller than the denominator. Okay. So if I think about it in my brain, I'm thinking about breaking this up into 5 parts. Well, we did that for you. So 3/5 would be, this one would be 1, 2, 3. So right here would be 3/5. Notice where it falls in between 0 and 1. Is it closer to 0 or is it closer to 1? It's closer to 1 because it's on that side. Okay. 7/10 would fall 1, 2, 3, 4, 5, 6, 7. So 7/10 would fall right there. Okay. If I was going on a number line, like up here, like right above that, okay, 3/5 would be like right there. 7/10 would be a little bit more past that. Okay? We're not just throwing a number randomly in between two integers. Okay? We're placing it where it should go. Now, to put fractions with different denominators on the same number line, we must make equivalent fractions with the same denominator.
You can fill in those blanks on your notes, and maybe we'll give them an example.
Yep. So for instance, let's just use 3/5 and 7/10. Okay. So if I use 3/5 and 7/10, and I want to put those on the same number line, okay, to figure out where they go, I first have to make these have the same denominator. So I'm going to multiply this by 2. 3 times 2 is 6. 5 times 2 is 10. So now these two right here are the same. They're equivalent. That's what we learned on Monday. Okay? And now, most importantly, I can compare those two. Okay? So if I put a number here on a number line, 0 and 1, we'll call this point A, and we'll call this point B.
This is just an example, so this is kind of right above number 1 there. This is like a separate example we're doing.
Okay? Which A or B should be on the left? Meaning, in between 0 and 1, which point should be closer to A? Or it should be closer to 0. Which point should be closer to 0? A or B? Why A? Because it comes first?
6, yeah.
No. Because 6 is smaller than 7, right? Okay. So that means on this, I would say that A is here and B would be there. Okay. You can see that in the shaded part too. Okay. That A is left of that one. Okay? Clear as mud. Love it. All right. So now let's place these on our number line. So first off, are they all the same denominator? That's the first thing you got to look. Are they all have the same denominator? Yes, they all have the same denominator. That's great, because now then you can just place them all on there. You don't have to make equivalent fractions. Okay? Are they all less than 1? Or are some of them less than 1, some of them more than 1? Or are they all bigger than 1? What are we going with here? All less than 1? Some like half and half? All greater than 1. Okay, so we lost all greater than 1. Okay, that one's gone. Some half and half again? All less than 1. You voted twice for the same thing. What's going on, Will?
Mr. Linsmeyer, what was our rule again?
What's our rule again? You guys wrote it down on the top of the page. I can't understand when you mumble, Asha.
Okay, we said what? The top number is, if it's bigger than the bottom, then it's greater than 1. But we don't have any. Look, 3 is
Is
smaller.
3 bigger than 5? No. 4 bigger than 5? No. 1 bigger than 5? 0 bigger than 5? Okay, so what are all of these numbers in between? What two numbers are all of these numbers in between? What? So what two numbers are they in between? Say louder, Lloyd. 0 and 1. Because if none of them are bigger than 1, that means that they're all less than 1. None of them are negative, so that means they're all in between 0 and 1. So on your number line now, you're going to make yourself a nice big number line. 0
And they already have
and 1.
the 0 and 1 and
0 and 1 are already on there, yep. Okay? And then halfway through is like half, right? Okay? So 3/5. Where do you think 3/5 should go? We'll go here. Let me recolor this. We'll go blue line here. Left or right of the blue line? Left votes. Left of the blue line. Right of the blue line. Rights have it. How far past the blue line? Like all the way towards 1? Right close to the blue line, kind of close to the blue line, right? Yep. Okay. So I would say somewhere, like in about here, yes? Would be A. Now we can go off of A for B. Left or right of A? On the left side or on the right side? Right side? Why right side? Why right side? Because it's bigger, right? Because 4 is bigger than 3. Yeah. We can go right over here for B. C. Left or right of B? We'll always work off of the last point. Left or right of B? Left? Left or right of A? Left? Left or right of the blue line? Left still? Okay. Closer to 0 or closer to the blue line? Closer to 0. Okay.
Yeah, 1 out of 5, not very many.
Yep.
Pretty small.
So let's go with C right there. 0 out of 5. D. So all the way over to 0. Yep, that's all the way over at 0. 0 divided by 5 is 0. So we got that right there. Yes? All right. What's the problem in number 2? They're not all the same denominators, right? So what do we have to do first? What do you got, Cliff? Get them all to 6, right? Okay? Because we already got 2 of them at 6. What would 2/3 be in a fraction over 6? So you multiply the 3 times 2 to get 6? Okay, so what would the top be? 4, do we agree with 4, 6? Because I multiplied by 2 to get that one, which means I got to multiply by 2 to get that one. Okay? 1/2. What is 1/2 in a fraction that has a denominator of 6? So what is the fraction? 3/6. Do you all agree with 3/6? Yeah. Okay. So we've got, are they all less than 1? Yes, no, maybe?
Let's check. Top number is smaller than the bottom number in all of them? Yes?
Yep, so they're all less than 1. So we're going from 0 to 1. Halfway is halfway. Okay? 4/6, left or right of, sorry, I gotta put my blue line in the middle. Left or right of the blue line? 4/6. Right to the blue line? Yep. B, 3/6. Left or right of A? Left of A? Left or right of the blue line? Couldn't hear you, Will. So is that the blue line? Will, can you do me a favor? When you're speaking, can you pick your head up so I can actually hear you?
You got the right answer.
You got the right answer, yeah. That's why I kind of wanted to hear you.
What are you saying?
It's the blue line? Isn't it the blue line? Yeah. Okay. That's what I thought you said, but I don't think sure. So it is the blue line because it's half. It's halfway there. All right. 1/6. How far left? Left? Near the 0? I'll go with that because it's only one of the 6 parts, right? 5/6. What you got? Because it's almost all of it, right? All of it would be 6/6. Yeah. So it'd be way over here. Yeah? Love it. All right, so we're going to kick it up a notch. We're going to go to the back side. Okay? Because with mixed numbers, it's actually easier with mixed numbers. Because when you place your mixed number, it's got to be in between this digit right here, the whole number part of the mixed number. That's going to be your left boundary. And then the next positive number. Okay? So this one is going to be between 3 and 4. That's the cool part about mixed numbers. It already gives you that lower part. Okay, that's the whole number part. Okay? same thing. We got to have the same denominator. But here's the cool part too. We only need to make an equivalent fraction of the fraction part. Okay? That's all we got to make an equivalent fraction of, is the fraction part. Okay? So mixed numbers are going to be between the whole number and the next highest number. So here for 3 2/5, we would be between 3 and 4. So I wouldn't be looking at any of these, okay, because it's not bigger than 4. It's between 3 and 4, and I would go 2/5 of the way. So I would be right there. Now, let's put these to work. Do we have same denominators all the way through? Yeah, okay.
You're a nice teacher.
Are we in what numbers are we in between? So the first one's in between what? 2 and 3? Next one's in between 2 and 3, right? Next one's in between 3 and 4. Next one's in between 3 and 4 also. So I gotta put 3 numbers on my number line. Okay?
Make sense, everyone?
A, 2 and 2/5. That's going to be between 2 and 3. Closer to 2. So I'm going to go there. B, 2 and 1/5. Going to be in between what two whole numbers? Between 2 and 3 still. Then what? So it's going to be right on top of A? Closer to 2 than A, right? So it's going to be between 2 and A. Yeah. C, going to be in between 3 and 4, closer to close to the middle, right? But it's actually closer to 4. D is going to be in between C and 4. Yep. So it looks like that. Okay? You tried now, was it number 5?
Yeah, but should we set them up with
Okay.
denominators first?
Okay? Yeah, let's do that one. We'll set you up with denominators first.
Then we'll let you.
What's our common denominator? What does 2, 3, 3, and 6? What would it be a common denominator for all of those? 6. Yep. Okay. So 1/2 is how many 6? 3 6. 2/3 is how many 6? 4 6. 1/3 is how many 6? 2 6. Okay?
D is already there.
Yep, and D's already in the 6. Okay? So put those numbers on a number line, please. So the numbers that we have on our number line are 4, 5, and 6. Okay? A, where's A go? Where does A go on my number line? Between what? Between 5 and 6? Where between 5 and 6? trick question, because it's already in the problem for you. Where should it go? Where should 5 1/2 go between 5 and 6? Yeah, we could add little half lines. Where should it go? On the half line, right? Because it's 5 1/2. Oops, go on. Come on, Dan.
I know what color you wanted.
A there. Okay? B, where should B go?
5.
Where should it go? What two whole numbers should it be in between? B? So it should be between 5 and 6. Okay? Left or right of A? Right of A?
A was 3, 6, and B is 4, 6. 4 is bigger than 3, so we're going to put it to the right.
Oh.
Right.
C, where should C go? Between what two numbers? Between 4 and 5. Left or right of the blue hash mark? Left. D, where should D go?
Any brave volunteers? Letter D.
Letter D, where should it go?
We got a big 5. So
Where should it be in between? It should be between 5 and 6, but closer to between B and 6. We got that. Okay? So, today, you're going to get two things. You're going to get your B5 homework, that's going to be gold. You're going to get a green formative assessment. This formative assessment is going to be your Friday. That'll be your Friday work to do during the day. B5 is going to be due tomorrow. Okay. Tomorrow will be an in-class work day because the afternoon class doesn't meet. So you'll have plenty of time to get caught up on all things that you have missing and all that fun stuff. Okay? Do not try and rush through the green worksheet, or the green formative. Okay?